Hello, so this is a little bit of an instructional video about production roasting. So this is roast number 4 going into the roasting drum of today. And what I thought I would try and do is just explain the process around how I approach an actual production roast. So I'm roasting the Pantano, which is a core product of ours. It's a low altitude, relatively low density coffee. So I tend to roast these early on in the day when the roaster has a lower thermal mass. So I start with decaf, I then go through to Brazil coffees and then work my way up in density and altitude. So today I'm going to be finishing on our dark roast, and I have a Burundi, a people from Burundi, which is a small dense coffee. So what I've done is I have a pretty strict protocol between batches, and I'm running via 1, 2, 3, 4 thermocouples, a set of data through to Cropster, which is a third-party software suite, and I work with a pretty strict protocol between each batch, the ejection of one and then the introduction of the next. So I'm just about to put the roast in, which on this machine is 200 degrees Celsius on bean temperature. And what I do is I press go on the Cropster machine, on the Cropster software, and I introduce coffee through the green bean auger chute, and get the coffee into the drum and insert my first gas, which today I'm using 78% of full gas. That I'm using because the temperatures in the UK have changed some over the past few weeks. We're now down to 10, 11 degrees Celsius, probably 13 or 14 ambient inside of the roastery. And what that means is that the raw coffee begins to drop in internal core temperature. And where my summertime, late summer recipe would have been 70% gas at the introduction of the coffee, because the green beans would be relatively warmer internally, so they need less thermal input to change that energy. Today I'm using 78%. So we work on 78% gas in the drying phase. So that's the phase in which you drop the coffee into the roasting drum, and you're looking to drive the moisture out of the coffee. Just whilst it's on my mind, at the end of every batch, we will cool coffee in the cooling tray, and then once we've probably had 4 to 5 minutes worth of cooling time, which neatly forms the between batch protocol between the exit of one batch and the introduction of the next, cool the coffee, and then I drop it into our weighing scales. This is the O-House Defender 5000. It is 1 gram accurate. So 9 kilos has gone in. I've weighed out 7.902 kilos of coffee out. That will now then get entered into Cropster, so that there is a reference of the weight loss, and the reference to the weight loss is a measure of repeatability within the roast. It's one of the factors that I look at the end of a roast production day. I will also always put inside of the roasting bin a little data sheet that tells post-roast production what was roasted, on what date, and the denomination in which I feel we should package it. So today, being a Wednesday, it's a single origin roasting day. On single origin roasting days, obviously I roast single origins for e-commerce, the farmers markets that I do on a weekly basis, and any top up in the commercial side of the business. So if I've received orders Mondays and Tuesdays, of which I roast coffee for either the shelf or for orders, I'll look sometimes on a Wednesday to top those up. So we're now 3 3/4 minutes into the roast. There has been a differential in roast curves because the raw coffee that's gone in is colder than it has been, as per the recipe. So what I'm now doing is 78% gas at 135 degrees Celsius. I'm dropping down to 75%, and at 140 degrees Celsius, I'm going to taper it down again to 70%. So what I'm now doing is I'm trying to, through the life cycle of the roast, I'm trying to taper away energy. So as water is driven off, the cell structure becomes a bit more brittle, and it takes less energy to change temperature and colour. So I like to taper those down as the roast goes on. On a normal roast for this Pantano, which I'll be roasting for a filter style roast, at 4 minutes and 59 seconds and 155 degrees Celsius, I'm going to drop from 70% gas down to 60, which we're just coming up to now. Okay, and each time an event happens inside of Cropster, I look to mark the event on Cropster itself. That is so that when I'm reviewing the roast data at the end of the production day, I can see where and what happened throughout each batch to make assumptions based on success or failure, and also a measure then of repeatability. And as a production roaster, our prime goal is to hit our marks, and our marks are total roast time, total end temperature, and roast curve repeatability as well. We will then measure colour to note accuracy batch by batch, and that's something that we would do later on in the day through quality control. We would potentially pull out any anomalies or any roasts that fall outside of our given range, but a good production roaster should be able to be pretty close to the mark, should you make sure that your routine batch protocols are working well, and your thermal management through gas input is working well, and also as long as you've taken note of any of the weather conditions on the day. So today being a Wednesday in the UK, it's the 1st of November. It's a little rainy on the outside, so that will have an effect on this single pass throwback. So it may require a touch more energy in the early phases, but because there's more moisture in the air, a little less gas at the end phases. So we're at 7 minutes and 14 seconds in. I've now dropped down to 40% gas. I'm approaching 135 degrees Celsius. And at 187.7, I'll drop down to 30% gas and start thinking then about the entrance into first crack, which is a very important phase within roasting, and it's where the product changes its state from being a seed into an actual roasted coffee bean, something that's then extractable and can form a brewed liquid, which I'm actually enjoying now, the Lechera Torres from Peru. So 190 degrees Celsius is just coming up, and at 192, I'm just going to take another 5% gas out as we go into this first crack cycle. Right, so 25%, 8 minutes and 20. By this, we should be hitting first crack at around 9 minutes. 9 minutes and 3 is the target. I tend to roast coffees for somewhere between 10 and a half and 11 minutes generally. I find with the airflow, which is a fixed airflow on this Probat, and the gas, so there's a nominal amount of gas available to combust, of which each machine is slightly different. And I find that an 11-minute, 10 and a half to 11-minute roast is where we're at with this. So, first crack is now 198.1 degrees Celsius. Just making a small adjustment. So, at 200 degrees Celsius, 0.6. I'm just dropping the 20%, and I'm just going to very, very slowly taper these down. This Brazil, I roast a touch different to some of the other coffees. I like to be very, very sensitive with the gas coming out. You'll note I've now switched from the Cropster Probat interface into actually using the LCD screen on the Probat. This is just habit. Is to make sure that any of the adjustments that I make are accurately inputted into the machine, and there's no data loss between the two. At 204.1, I'm just going to take the gas out. Now, that's at a roast development of 12% from first crack. With this coffee, I'm looking to do a post first crack development time of about 1 minute 45. I like texture, I like to see sweetness. I don't want it to be too bright in acidity. I want it to be nice and balanced, because this has to be a versatile coffee, and that development's great. So turn the agitator on, turn the fans on at 1 minute 45, and extract the coffee out of the roasting drum. So, Probat has a very wide open cooling tray, and I found it most effective to, once the coffee's come out of the drum, stop the agitator and just gently move the beans around so the full bed is completely covered, rather than there being an ebb and flow with the agitator. That then means that there's an even drawdown of cool air through that mass of coffee. And I just found through experience that it's a much more effective way of cooling the coffee. So it's just something that I do. So that roast is now ended, and Cropster has started an automatic timer for their between batch protocol. I will complete the roast, noting roast times, and set everything up then for the next batch. So today, the between batch time frame is going to be somewhere close to 5 minutes, and that's through the exit of one and the input of the next. So I've now got 5 minutes to be able to load up the next coffee, and I like to do that pretty early after the first one has come out, and that's just through experience and repeatability. It's something I've done for a very, very long period of time. So in goes the next coffee into the auger, ready to go. I'll get an empty bin, which I'll place on our scale, set that to 0, and note the temperatures now. Now this is the time where if you need a trip to the bathroom, you can pop and do that. Maybe pick up an email or something along those lines. I like to try and keep focused throughout the roasting generally, and just get yourself set for the next batch, making sure that you adhere to the same rhythm and the same routine on a batch-by-batch basis to make sure that there is good repeatability batch by batch. So at 4.5 minutes on today's temperatures, I'll make sure that I'm in a ready-to-go state. I enter the coffee using my exhaust temperature, and I use 195 degrees Celsius. That is my period in which I allow the roaster to cool down to. I then start inputting some gas, and that tends to be between 15 and 20% gas, but it's generally 15% gas. I like to then drop the coffee on the upward slope rather than the downward slope in temperature. I've just done that for many years, and I like to make sure that I remain in that cycle. It's just the way that I've always roasted on this apparatus. I hope you've enjoyed the video and you found this little insight into a day's production roasting or a single cycle of production roasting useful. Hope to see you next time.